All right, let's get going here. Again, both of these are a review of what we've been doing earlier this week. First part, we want to find the prime factorizations, which means we're going to use what? How are we going to factor these? We're going to use a factor tree. So who wants to help me with the 90? Travion? 9 and 10. All right, is either of those prime? No, so we need to keep going with both of them. Okay, so how about that 9? Travion? 3 and 3. Okay, are those prime? Yeah, those are prime. We can't factor them anymore, so we'll circle those. How about that 10? 5 and 2. Okay, and those are both prime, right? Okay, so when we write the standard form, we need to make sure we write them in what order, Travion? Least to greatest. So I know it's kind of hard to read, but you've got one in front of you also. What's that going to look like when we go least to greatest? Okay, so we got the 2 times 3, and then another 3, okay, times 5. All right, so there's your standard form. Again, this is kind of a simple tree, so if you don't mark them off as you get them, you're probably all right. When the trees get a little bigger, you'll probably want to make sure you get everything by marking them off as you use them. So there's your standard form. We can make this a little bit simpler, a little bit shorter by writing it in exponential form, which would be what, Travion? Good. So when we have a repeated factor like the 3 times 3, we can write that as 3 squared, save us a little bit of time. Not a whole lot in this case, but it's a little better. So that's your exponential form. Don't forget to box your answers also. All right, how about the 160? Who's going to help me with that? Jack? Okay, so how do we factor 160, Jack?
4 and 40.
Okay. Now, that's not the way I would have done it. Since the 160 ends in a 0, I probably would have started with a 10. But this will still give us the same answer, right? So if we had done 10, it would have been 10 and 16. So we just basically take the 0 off, right? Let's go with the 4 and 40, though. So 4 would be what? 2 times 2, and those are both prime, right? How about the 40?
4 and 10.
4 and 10. Those are both composite, so we need to keep going. How about the 4?
2 and 2.
Okay, and the 10?
2 and 5.
All right. So what's that standard form going to look like then, Jack?
2 times 2 times 2 times 2 times 2 times 5.
How many of those were there? 5 of them?
Yeah.
Okay, let's make sure we got them. 1, 2, 3, 4, 5. That looks good. And then we've got the 5. All right, so there's your standard form. This one's going to be a lot shorter with exponential form, right, Jack? What's that going to be?
2/5 times 5 1.
2/5, like this?
No. 2 to the 5th power.
Okay, 2 to the 5th power times 5. And we could have done this on the first one also. I'm going to put it on this one. If we want an exponent on the 5, what would it be, Jack?
1.
We could put a 1 there. So it could be 2 to the 5th times 5 to the 1st, or you could just make it 2 to the 5th times 5, and that's it. All right, and again, don't forget to box your answer. All right, how about the 180? Jayla, can you do that one for me? Okay, so this one ends in a 0 also, so we can do 18 times 10. And then how about that 18? 3 times 6. The 3 is prime, right? 6 is 2 times 3. And then how about the 10? All right, so what is the standard form going to be? 2, okay. 3 times 3. And then times 5. Okay, good. And then how about exponential form?
2 to the 2nd power. 3 to the 2nd power times 5.
Perfect. And again, if we wanted an exponent on that 5, we could put 5 to the 1st power if we wanted. What's another way of saying to the 2nd power? Instead of saying 2 to the 2nd power, we could say 2 squared. So we could read this 2 squared times 3 squared times 5. on these problems with the square roots, I mentioned this earlier, but you might know the answers without doing any work, but you need to show the work that shows us that you understand what a square root's doing. So the first thing we want to do before we write our answer is we're going to rewrite the problem so that the radicand is what? In this problem, what are we going to put in there? 8 squared, right? So the first thing we're going to do is we're going to rewrite it so the radicand is a perfect square, is a square. So instead of 64, we're going to write 8 squared. That's what goes on the inside of the square root. Now, the square root and the square are going to, they're going to cancel each other out. So we're going to cancel the square and the square root out, and we get 8. Okay, one other thing I want to mention, I've seen a few people doing this again today. We want to make sure that when we write an answer, we don't want to write it like this. Okay, this is what we would do for a division problem, and I know the square root kind of looks like the division symbol, but it's not. We don't want to write our answers on top, but we're going to write them off to the side like we did here. So make sure you're showing your work, change the radicand to a square, and then the square cancels with the square root, and that gives us our answer. All right, so how about the 121? Who can help me with that one? Amante? So first thing we're going to do is write it as the square root of what? The square root of 11? Not quite. 11 squared. So 121, our radicand here is the same thing as 11 squared. So we're just changing the radicand. And now the square and the square root can cancel each other out just like it did on the last one. And that leaves 11 all by itself. All right, how about this one? Do we need to change this 7 times 7 to 49? No. So what we want to do is we want to write the radicand as a square. So instead of multiplying this out and then starting the problem over, what can we do? Just write this as 7 squared, right? So 7 times 7 is the same thing as 7 squared. So it's actually exactly the same work, but we don't need to multiply it out. We don't need to know that this was 49 to begin with. We're just going to rewrite this 7 times 7 as 7 squared. And now that we've done that, the square and the square root are going to cancel each other out, and that leaves us with 7.